All right, a warm up before you get started. A path is built around four congruent circular fields. The radius of each field is 100 feet. How long is the path? Find the exact answer. So my hint to you would be try to find these four straight segments, and then think about these four, whoops, I was supposed to change colors. These four quarter circle arcs. Go ahead and pause your video. Try for yourself. So I came up with four segments that were 200 feet each, and then four quarter circles that were 50 pi each to get 800 plus 200 pi feet. Now you can leave that answer because that is exact, which is wonderful. Or if the problem had asked you to round, you maybe could say 1,428 feet would be to the nearest foot. But again, it didn't say, it said find the exact answer. That is exact. We are good to go. Our focus for today is going to be all about finding areas of circles and sectors. So the first thing to think about is, what is area? Well, we've talked about perimeter. Perimeter is the idea of walking around the outside of a figure, collecting the segment lengths in linear measurements. Area then is going to be how much paint it takes to fill in the wall. So if I think about a rectangle, that is, we'll say 3 units by 6 units. So 1, 2, 3, 1, 2, 3, 4, 5, 6. So whatever these units are, if I break them down into 3 by 6, and then I count up how many squares I have created, in this case, 18 units squared. So had this started as, let's say, 6 feet by 3 feet, well, then each one of those pink squares would be 1 square foot. So I would have 18 feet squared. The area of one individual square from previous classes is side squared. Area of a rectangle is base times height, sometimes referred to as length times width. The area of a triangle is going to be 1/2 the base times the height. That has to do with the idea that all triangles could be considered part of, or half of, rather, a rectangle. Where's my undo? Erase that. And then finally, the area of a circle, which is going to be our focus for today, is pi r squared, which is funny because pi are actually round. All right, area, again, focus for today, pi r squared. The way you can remember this as opposed to the circumference is that you have this square unit because area is measured in units squared. Find the area of a circle with a diameter of 10 centimeters. Well, my formula relies on knowing the radius. So the area is going to be pi times the radius. If diameter is equal to 10, then r is equal to 5. So the area equals 25 pi centimeters squared. That is your final answer. No need to round decimals. No need to approximate. 25 pi is a great final answer. All right, the next one. Find the circumference. So I'm looking for the circumference, which I know is equal to 2 pi r. I was given the area is 49 pi feet. So I know the area. I'll have the ability to find my radius. 49 pi, 49 pi centimeters squared. Sorry, not feet. Centimeters squared. Did I say feet? 49 pi is equal to pi times r squared. Divide out your pi's, take a square root. R is equal to 7, which means that my circumference is equal to 2 times pi times 7, or 14 pi centimeters. And again, that's going to be to the first power because I'm looking for the circumference, which is a linear type measurement. Last one. Find the radius of a circle with an area of 176.7 feet squared. So once again, I'm given the area, 176.7. That's going to be equal to pi r squared. So in my calculator, I'm going to take 176.7, divide by pi. I get 56.245. Then I'm going to take the square root of that answer, carrying as many decimals as possible. R equals technically plus or minus, but because we're measuring the radius of a circle, we're going to keep the positive 4.99. We'll go 7, and that will be feet for the measurement of a radius. Okay, so that was a review from previous classes. Let's talk about our new concept, which is finding the area of a sector. Well, the sector is like thinking about the slice created by a given arc. So in the last video, we learned how to find the measure of this arc. Now I want to find the area that is created by that arc. Well, the area of red is going to be smaller than the area of the blue, even though each one of these arcs had a measure of 70 degrees. The reason why those measures are the same is because they have the same central angle, but the areas are going to be different because the size of your circle is different. The sector area is going to be in ratio with, that was supposed to change colors, is in ratio with the area of the full circle. And that ratio is going to be equal to the measure of the arc relative to 360, the full degrees measuring the outer arc. So our sector area, just like before with circumference, is taking a fraction. Instead of the circumference, though, we're going to take a fraction of the area, which is pi r squared. All right, our sector area is a fraction of the circle created by that arc times the area of the whole circle, which is pi r squared. So find the area of each sector formed by PSQ. Well, PSQ is forming this sector. So the area of my sector is going to be equal to, if I use my formula, the measure of the arc, which was 135 over 360. So that's finding a fraction of the full circle, which would be pi r squared. 135 over 360 is 3/8 pi times 225, which means the area ends up being 675. So just multiply the 3 times the 225 over 8 pi centimeters squared. You can leave that as your exact answer. That is a beautiful, wonderful answer. Okay, well, let's talk about then the blue sector. Well, the blue sector is going to be some fraction of my circle. In this case, I would take 360 minus the 135 that's already been used, and I get 225 times pi times r squared. Now, if 135 over 360 gave me 3/8, then 225 over 360 should give me the rest of the circle, which would be 5/8 pi times 15 squared, or times 225 rather. 225 times 5 divided by 8. So you call this 225 instead. Area equals 1125 over 8 pi centimeters squared. This time we are given the area of a sector. So I'm told this is 48 square feet. So 48 square feet is equal to a fraction of my circle times pi r squared. Well, this question asked me to find the area of S. The area of circle S is this whole area colored in. Well, that's all right here, pi r squared. I don't know what my radius is, but that doesn't matter. I don't want the radius. I want to find my area. So all I need to do is get A by itself. I'm going to multiply both sides by 360. So I get 48 times 360 is 17280 is going to be equal to 135 times area. So I'm going to divide by 135 and I get 128. Oh, not 100, 1,280. Literally just 128 feet squared will be my area. Now I can check that because 48, no wait, that's not how I want to check. I mean, I can't check that way, but I'm going to check it by saying 135 out of 360, which was 3/8. 3/8 times 128 is, oh, what do you know? 48. Okay, example 6 of 7. We're getting there. Find the amount of teal paint needed to paint this wall. Well, if I wanted to paint this whole teal wall, all filled in, I would have a rectangle that measures 36 by 26. But I want to cut out this square that happens to measure 16 by 16. And I want to cut out this semicircle that has a radius, well, it has a diameter of 16, so a radius of 8. So pi times 8 squared. So what I'm going to need to do is 36 times 26, the area of that rectangle, is 936 minus my orange square, 16 times 16 is 256, minus my pink semicircle, which is 64 pi. 936 minus 256 gets me 680 minus 64 pi. That, with feet squared for units, is how much paint I would need to paint that wall. Now, you can leave it like that, okay, because that is an exact answer. That is great. 68 minus 64 pi also happens to be 478.94 square feet. So you can combine these two, but this stays as its own because 64 times pi, while pi is a constant, you want to keep that 64 stuck with that pi. Order of operations would say multiply the 64 and the pi first. All right, that's where we stop for right now. I know it says example 6 of 7, but we're going to pick up with our last concept, which is population density, in a different video.